So this video is about molecular geometry. The question is asking, what's the molecular geometry of NH3? Well, for non-expanded octets, so the regular standard and honors chemistry shapes, you're going to have these 5 shapes of molecules. You can have linear, where the central atom is bonded to 2 elements and no unshared pairs of electrons. Bent, where that central atom does have unshared pairs, that pushes those 2 things bonded to it down and makes it bent. Oh, and notice I'm using A and X. Those are placeholder elements. They're not real elements. They're just standing in as an example. Okay, so you can have linear or bent if you have 2 things bonded to the central atom. If you have 3 things bonded to the central atom, you can have trigonal planar or trigonal pyramidal. So 1, 2, 3, 1, 2, 3. The difference is the unshared pair. This has no unshared pairs. This does have these electrons, an unshared pair right here. Trigonal planar, these 3 atoms are on the same plane. It's like a flat molecule. But here, this unshared pair pushes this atom, and this atom down to make kind of a pyramid. So that's the difference between these 2. Then there's tetrahedral. That's where you have 4 atoms bonded to the central atom. Okay, well, what about NH3? Looking at it, it looks like we're going to have 3 things bonded to the central atom. So it's going to be trigonal planar or trigonal pyramidal. But which will it be? Oops, let's draw it out. So we have NH3, N, and then H, H, H. I'm going to add N's valence electrons. It has 5. Hydrogen has 1 valence electron. I'm going to connect these valence electrons in bonds. Looking at the shape of NH3, what I see is 3 atoms bonded to the central atom and an unshared pair. That unshared pair pushes these guys down into kind of a pyramid shape. So that makes NH3 trigonal pyramidal.